So in this video, we're going to review factoring. The entire video should pretty much be review for you, so I'm going to go pretty fast. And since you can pause and rewind, I'm not going to feel bad about that. And this should all be reviewed as I said. So what does it mean to factor? To factor means to take an object and to write it as a product, which means two things or two or more things being multiplied. Factoring is one of the key skills in algebra, and we use it almost on a daily basis. Okay, the way I see factoring is as a pyramid. We start at the most basic level, and we work our way up to harder levels. Today we're going to cover every level on this pyramid except the top level, which is only applicable to certain types of expressions. So we're going to hold off on that until Chapter 3.
So the first level on the factoring pyramid is, generally speaking, the simplest, which is to take out the greatest common factor from every term in the expression. Generally speaking, that means to find the smallest variable, or smallest power of the variable that's common to all terms, and then factor out the greatest common divisor of the coefficients. So in this case, we have three terms, 18x cubed, 12x squared, and 30x. The smallest power of the variable that's common to all three is x to the first power. The greatest common divisor of 18, 12, and 30 is 6. So 6x is the greatest common factor between these three terms. Now, what I want to do in the next line is a step that you may or may not do naturally, but when the problems get a little bit harder, it's a good idea to write things out so you can see exactly what's left when you take out the greatest common factor. So I'm going to write each of these terms as a multiple of the greatest common factor, 6x. So you'll see that in red. So 18x cubed is 6x times 3x squared, 12x squared is 6x times 2x, and 30x is 6x times 5. Once I've identified what's left when that greatest common factor is factored out, I can take that 6x out from all three terms and replace what's left inside a set of parentheses. So in factored form, 18x cubed minus 12x squared plus 30x would appear as 6x times 3x squared minus 2x plus 5. You can verify that this is correct by multiplying the 6x back into all three terms and making sure you arrived at the original problem.
Okay, we're actually going to go into some special patterns. The first special pattern is what we call a difference of two squares. Something squared minus something else squared. This expression will always factor, and we're going to see this quite a bit, so we want to be very comfortable with it. And the way it factors is that first object that's being squared plus the second object being squared times the first object being squared minus the second object being squared. Okay, so if you don't like my words, this is the same as saying a squared minus b squared will always factor, and it always factors in this form, a plus b times a minus b. And yes, that could be written in reverse. It could be a minus b times a plus b. You'll get the same answer. Multiplication commutes, which means the order does not matter. Okay, now, by the way, FYI, a sum of two squares does not factor in real numbers. Okay, so that's a common pothole that we should step into. So we need to make a note. A squared plus b squared does not factor, DNF. Okay, sums and differences of odd powers also always factor. And there are formulas in the book, but I'd rather you not memorize the formulas. I'd rather you understand where they come from. So I'm going to take a little time and explain that here. So let's start with a sum of two numbers being cubed. Let's do x cubed plus 2 cubed. Okay, so the first thing to notice is that this will always factor with a binomial times something larger than a binomial. Okay, we know from past experience with polynomials that the binomial term is always going to be the cube root of the first term, which is x in this case, plus the cube root of the second term, which is 2. In other words, the objects that are being cubed. We keep this sign the same. Now, when we expand and things are in descending order in terms of the power of the variable, we know that the first term times the first term always ends up in the final answer. So I know that x times something will equal x cubed in the final answer. That makes finding this piece very easy. That's got to be x squared. Similarly, if we have constants in both expressions, we know that the last times the last will always be in the final answer. So we can easily figure out what term has to go in the last slot here. It's got to be a 4 because 2 times something needs to be equal to 8. So the only mystery here is what goes here in the middle. And I'm going to maybe do something a little bit awkward here on the screen, and we have a chance to practice this in class. But we can use our fingers to determine what goes there in the middle. So here's what I want you to do at home. Take your 2 index fingers and place them on the inside of each expression. Okay, so I'm on the inside of the x plus 2, and I'm on the inside of the x squared plus blank plus 4. Put a plus there. Okay, so I do this, and I look at these 2 terms, and I know we're going to multiply those 2 things together. So mentally, I think, okay, I have a 2x squared. Now, we notice that in the final answer, there are no x squared terms. So this 2x squared has to get canceled off by a negative 2x squared somewhere. Okay, now how do we figure out how that's going to happen? Take your fingers and slide them 1 slot to the outside. Okay, so I slide my fingers 1 slot to the outside. I have an x, and then I have a missing term here. Okay, that x times the missing term has to cancel 2x squared. So x times something will equal negative 2x squared, and that allows me to determine that this needs to be a minus 2x in this slot. And since I'm now in descending order, I know I'm finished. I have an x squared term, I have an x term, and I have a constant term. Let's do another one with a larger power besides cubes, because it works for larger powers as well. Or let's try x to the 5th plus 32, where 32 we can see is 2 to the 5th power. So how will this factor? Well, there's going to be a binomial term, and then there's going to be a term with more than 2 terms. We don't know exactly how many at the moment. We'll find out as we go. So for certain, we know that the 5th root of the first term goes in the first part of the binomial, so that's going to be x. And we keep the sign the same, and then we take the 5th root of the 32, which gives us 2. Now, first times first will be in the answer, so this is going to be an x to the 4th, easy. And last times last will be in the answer. This is a 16. Easy enough. At this point, we need to employ our fingers. So we again take our 2 index fingers, place them on the 2 inside terms of each quantity. Okay. Mentally, I can see that that's a 2x to the 4th. Somehow that 2x to the 4th needs to get canceled. What will cancel it off? Well, slide your fingers 1 slot to the outside. So I've got an x and I've got a blank. So x times blank will give me negative 2x to the 4th. Okay, do a little bit of thinking. That should be negative 2x cubed to get that done. Okay, now, what comes next? Well, let's ignore the x to the 4th and pretend this is the inside term. Place this finger back on the 2. Mentally, you multiply those in your head and you get negative 4x cubed. That has to get canceled because there are no x cubed terms in the final answer. What will cancel that? We slide our fingers 1 slot to the outside. X times blank will give me 4x cubed. Answer there is a positive 4x squared. Looks like we need to do one more term because there's no x term yet in the right quantity. So put this finger back on the inside term. 2 times 4x squared will give us 8x squared. That has to get canceled by something. So we take this finger, put it back here, slide them out 1 slot, and x times blank will give us negative 8x squared, and the answer there is going to be minus 8x. A little bit awkward on the computer screen. I know we'll have a chance to practice that in class. Hopefully you find it helpful. Okay, trinomials sometimes factor, and there may be some methods you learned in the past, but from my experience, it's best to just plug and chug with trial and error until we get the correct answer. So if trinomials factor, they're going to be 2 binomials. And we look and see what are the factors of 8x squared, and we place those in the first part of each binomial. So for example, a 4x and 2x is one way to get 8x squared. It could also be an 8x and a 1x. And then we look for factors of negative 15. and we just trial and error with the combinations until we come up with the right solution. So let's see here. We could go with a -3 and a +5 and see if that gets us anywhere. So what does this give us? This gives us 10x and a -12x, so that's not correct, so we try again. We could go with a -5 in this slot here and a +3 in this slot here. And now we're going to get -20x plus 6x, which is -14x. So there we have it correct. Now, factoring by grouping. This is really using the greatest common factor technique 2 or more times. So in general, we say we're going to group 2 of these terms together, and we're going to group the other 2 terms together and do a GCF factoring. If something good happens, then we can factor again. So if I group those first 2 terms together, I notice they both have a common factor of x squared. So that would look like x squared times x plus x squared times 4. The second 2 terms have only a common factor of -1. So -1 times x, okay, plus, this is tricky now, -1 times 4. From the first 2 terms, we can factor out the x squared. When we do that, we're left with x plus 4. And from the second 2 terms, you can factor out a -1, which leaves you with x plus 4. So now you have 2 terms, and you know that those 2 terms have the common factor of x plus 4, which means you can factor out the x plus 4 from both of those. So there's where you've used the greatest common factor 2 times. X plus 4 times what's left over, which is x squared minus 1, and you say, ah, eureka! That's the difference in 2 squares, so that can be factored as well, and so we can go one step further to fully factor this expression. X plus 4 times x minus 1 times x plus 1. Now, you may or may not have seen these in the past, but you will start to see them here. So these are fractional exponents. You could also even have negative exponents and be asked to factor. So what do? Well, really, we don't do anything different. Okay, we factor the greatest common factor, and what that has been is the smallest power of x that goes into both terms. So what is the smallest power of x in this expression? Well, it's x to the 1/2. So let's factor out x to the 1/2 from both pieces. The second one's very easy to do. Here we have to do a little bit of thinking. Okay, x times 1/2 times x to the what would give us x to the 5/2. Okay, well, the rule says when you multiply spaces, you add exponents. So 1/2 plus something would give me 5/2. That would be 4/2, which is the same as saying x squared. So now we can we can factor out the common factor of x to the 1/2, and you're left with x squared minus 1, which again factors the difference of squares. Okay, and finally, you may have to use different levels of factoring on the same problem. Okay, you've already seen a few examples of that, and my advice is to say, always do the lowest level first. So if you go back to the pyramid, GCF is the lowest level in the pyramid. It's the easiest one to do, so I would always start there, because it will sometimes make your number smaller. Okay, this is a trinomial, and I'll tell you right now, it does factor, but it's going to be tough to figure out what it factors as if you don't do GCF first. So I noticed that 9 is a common factor that can be pulled out, and you're left with x squared minus 4x minus 5. And now I'm in a much easier trinomial to work with. Okay, so I do the easiest level first, and then work my way up. X minus 5 times x plus 1.